Let's differentiate two functions which require the use of a product rule. Let's remind ourselves of what the product rule is. So if you want to differentiate a function of x times another function of x with respect to x, right? So if you have a product of two things that both depend on the variable of interest that you want to differentiate with respect to, then you're not allowed, so let's emphasize this, you are not allowed to differentiate the first one and the second one. You cannot distribute that derivative operator across that multiplication. You can distribute derivatives across addition, not multiplication. So we have to give ourselves a rule on how to deal with this. And the rule is, when you differentiate a product of two functions, you can differentiate each one separately, but you have to carry the other function with you. So I can differentiate the first function, but I carry the original g of x with me, right? So I just differentiated f of x, and then I copied down g of x, and I add to that the opposite of what I just did. I copy down the f of x, and I differentiate the g of x. And this will work for any number of products. So let's do this with our two functions here. I want to differentiate with respect to x, f of x, which is e to the 3x times 2x squared plus the square root of x. And notice that I'm writing that square root of x as x to the 1/2, because I know that when I differentiate it, I want to view it as something I can use the power rule on. So when I differentiate this product, right, I've got this times this. So I differentiate the first term, e to the 3x differentiated with respect to 3x is e to the 3x. And then by the chain rule, I have the derivative of 3x, which is 3. Right, so this, oops, where'd it go? This right here is the derivative of that term. Now, the product rule tells me to copy down the term that I have not differentiated yet. Right? This right here is just a copy of that term. And now I do the opposite. I add the opposite of what I just did. So now I will add a copied down e to the 3x and a differentiated 2x squared plus x to the 1/2. So this will differentiate to 4x plus 1/2 x to the minus 1/2. Right, so in fact, let me try to color code this. Let me turn this to yellow. 3e to the 3x. Right, this is my derivative, because this is the copied down version of my first function. Oh, sorry, nope. What do I want to do? That's my first part of the function. This is my differentiated first part. So that's my first part. This is the differentiated first part. This is the second term in the product. This is it just copied down. Second term, that's it just copied down. And then what's next? I have copied down my first term. There's my copied down first term. Copied down first term. Copied down first term. And then in red, I differentiate the last term in the product. And so hopefully that made the pattern just a little bit more clear. And hopefully the second derivative will make it more clear. Let's differentiate g of x with respect to x, which is the natural log of x times 1 plus x to the minus 3. And note, I already know that I'm going to differentiate, so why not write that 1 over x cubed as x to the minus 3 so we can use our power rule. When we differentiate, we choose one of the products and differentiate it, we copy down the second term. And remember, because we're adding, it doesn't matter which one you choose to do first. So let's just copy down the natural log, which means we'll differentiate the 1 plus x to the minus 3. So this will differentiate to 0 minus 3 x to the minus 4. And we'll add to that. Now let's differentiate the natural log. And we'll copy down the 1 plus x to the minus 3. Right, so there, that's it. That is the product rule. We're done taking the derivative. So the calculus is over. We can clean it up a little bit with some algebra, right? If we wanted to, we could write this as minus 3 natural log x over x to the 4 plus a 1 over x plus a 1 over x to the 4. Right, but we were done with the calculus at that step.